Welcome on this early morning. I hope you all had your coffee or drinks to get you up and running. You're here for a session on instrumentation in .NET and Azure for cloud applications. My name is Alex Thissen. I'm from the Netherlands, and I work at a company called Xspirit, and we help customers move to the cloud in general. And the step to the cloud is quite a big step. And the instrumentation part is something that is often forgotten. So with that, we really believe that if you have a DevOps mindset, that it should be all about the stuff that you build and you want to operate and run in production, that there should be some feedback loop. So you should be able to observe your systems. And this is from the Microsoft documentation. They have a monitoring checklist for if you want to do DevOps. I've highlighted 3 of the 4 that are there, make your systems observable. And then there's things with logs and metrics. And that's the main focus of today. We'll briefly touch on alerts and notifications. But the first 2 are like the big thing and the theme for this session. Now, okay, let's say that you're the DevOps engineer. And with that, I don't mean the people that build the pipelines, but the people, like the shirt says, we build it and we run it, we love it, we own the thing. And that's why we want to see what is happening when we're building things. So, just imagine on an average day, you pick up items from the backlog and you start working on it. You develop a new feature or something. And that's where you have your inner loop, a fast loop that gives you, isolated development and testing and a quick way of going back that if things don't work, you can fix them. But once you're happy and satisfied, whichever branching strategy it is that you use, you probably commit your changes, put it in the code repository, you'll run on the tests from your CI/CD pipelines, and then finally you put it out into your environment, so you start hosting it. And you might have multiple environments, but eventually will end up in production. And what I see a lot, and maybe you recognize this, is that production is just like it's there, but we don't really know what it's doing. So whenever the customers call, your website is down or it's behaving weirdly, that's where you're like, ooh, I would have wanted to know that or at least see what is going on. So the observability of your system is a big thing because if you can see what is happening in your environments, then there's a very rich second feedback loop that is, I think, essential for DevOps. So that's where you see how your application is behaving, how it's doing, and you get a lot of feedback from that. It might just be the errors, the things that go wrong, but it could also be usage. Which new features are being used and how are they being used. So very valuable. You need to gather that instrumentation data, like your panel with all the lights and numbers that tell you how things are going. And if you monitor those, that's where you get your outer loop. And that's where you can see what is happening there, change things accordingly through the inner loop, and make new items on your backlog if needs be to adjust accordingly with the things you found out from production. And it might just be that performance degraded because you had a new search routine or algorithm, and it turns out that it's not that behaving that as well, but as well as you would have thought. CPU usage might have gone dramatically up. So, but at least if you have this happy developer, loving the DevOps stuff. And the reason that this is important is that especially if you go to cloud, you build your application in a much more distributed way. And that means that there's many moving parts and they interact with each other. And if things go bad, it might just escalate. That's one side of the story. But it also means that you're dependent on other resources, other moving elements in your solution. And seeing how things work and where things are going or where there might be bottlenecks or things stopping or outages or whatever, that's where you need you need something to help you tackle that complexity of your application and getting some insights there. The area is called application performance monitoring, but it's not performance in the sense of how fast is this. It's more about how well is it doing. So it could be speed, could be resource usage like memory, the CPU, but also outbound connections and things like that, and the things that we put in there ourselves. Now, to help you out, there's a whole variety of APM, the Application Performance Monitoring tools. You can choose whichever one fits best, or you might already be using. Today we'll focus on Azure Monitor, because that's what the session is about. It's about doing this in Azure with all the tools integrated into Azure. All right, so let's zoom in on that just a little bit, because if you build a Azure-based application, preferably in .NET, but that's not really necessary, then Azure Monitor is the place where you want to observe and see all things. And it's comprised of two parts, the Azure Monitor logs and the metrics. The logs is where log analytics and the workspaces live, and the monitor for the metrics is where you can get insights. This is visible in multiple places, but you won't really see them as such. So it's there if you, for example, do a log analytics workspace with application insights. And we'll get to that later on. Now, the good thing is if you have a homogeneous environment with a lot of Azure elements in there, is that you'll get a lot of things from Azure for free, because it also outputs all the information to this location as well, to these resources. So for example, your Azure Active Directory, any interaction there, audit stuff, will be logged there. So you can find all the interactions with Azure AD there. Whatever happens inside of your Azure subscriptions, the activities, creation of resources, who does what, is also put into that logs. So you'll get those. And then with your Azure resources, combining resource groups, you'll get a lot of diagnostics as well. Most of the resources allow you to specify a log analytics workspace, which then uses the same thing, the same bucket to put everything together. So that's where you start, getting more and more application specific. But as developers, like I think most of you are, the cloud applications that we build, they could be based on .NET Core with NuGet packages and some telemetry libraries that you'll be using, allows you to send more than just the other stuff. Most of that stuff is what I like to consider control plane based, so it's the interaction with and the access to. The resources are also about the data and the stuff that is going on in there, so the applicational side of things. And your application obviously is much about what happens in my application, how many conversions did we get in the web shop, for example. Those could be really nice metrics. All right, so good thing is that if you take this entire stack, you've got everything covered in your application, from the underlying resources up into the actual logic that you're running. And you can combine it, and you can see all the information together. Focus for today. All right, so how do you do this application instrumentation? So there's 4 parts to this. So there's logging, that's recording stuff. There's tracing, following stuff. The metrics, that's numbers. And there's the health, and how are we doing? So with those 4, that's 4 things that your application can do to provide richer instrumentation. With this, how do you get that from your application? Well, the logging, tracing, and metrics are being pushed out, so you need to collect them, and then you monitor them, obviously, like we saw before. But the health information in general, but not always, is being watched. So it's being pulled from a health endpoint. And that's like, how is the application doing? Or are you ready to receive traffic, for example? Now this is how you can do things in the basis. There are ways for your health, for example, to push out metrics. So you can see statistics of the health information being pushed out as numbers. And you can interchange tracing and logging with one another, but that's where we get onto a slippery slope, because you should be very conscious of the distinction between logging and tracing. Once it's there, put it to good use, and there's a bunch of things that you can do with it. So just to give you an idea, obviously there's you can analyze things, see how it's going, time series, and then see the trends. There's alerting when say things go above or below certain thresholds or occurrence numbers. That's when you want to be notified. There's insights with dashboards, there's profiling if you really want to dig down in situations where things are not behaving as expected. And the metric streaming is, if it's high volumes of metrics, you can absorb that as well. I think this is maybe it's a bit of a crowded slide, so you can work your way through all the things that are mentioned there. But what I want to highlight here is that especially the first two columns are very important to keep apart. Things that you log are things that you might want to see a year down the line and still go back and see, okay, at this day, what happened with those 20 sales that we had. So important things that are worth recording for a longer time. It's sometimes used as trace information. We want to know in a production situation, why did this algorithm not behave correctly? Which things went in, the parameters or the arguments of a certain routine. And sometimes, you do the logging to find out what is going in and what is happening inside. So you sprinkle all of your code with all these log statements. And you might do, say log informational or something, so it's not that important. But it's not the tracing part. Tracing is about flow and things calling each other. So if you want to do that, then you should look into the area that is dedicated and intended for tracing. So my message here is don't misuse logging for tracing. And obviously it's a fuzzy area, so there's no strict rules there, but just be very conscious about it. Well, the metrics are about numbers, so that's quantitative things that you output and that you can measure and look at. The health we talked about, how are we doing, especially in, if you want to have alerts on availability, that's very useful, but it's also very useful if you're running a Kubernetes cluster, for example, because it can look at the health of your pods that are running and decide that it needs to recycle one of the pods if it's not indicating that it's healthy or maybe a degraded state. And the audit is something different as well. That's the things that you want to prove later on, usually security related, and it's not logging. So keep those distinct as well. All right. So I'll try to be brief in the first part of the logging because I think you've seen much of it, but just to summarize, so to speak, all the things that you can do with the built-in core FX libraries of .NET. So the flow that you have, if you want to log something, the gray area is your application. You'll use a NuGet package. It might be a different one. You might use Serialog or Nlog or something different. But the one that's built in is actually pretty good, I think. And that's your logging stuff that's coming out. It's a log message that you output. It has a certain category, and it has a level of severity. The logging framework, and then you have log providers, which sometimes confuses me. So what do you mean log provider? But it provides a place for the logs to be stored. And then you have the filters that allow you to tweak down the various information that is logged based on the severity or the destination. So you can be, have multiple providers listening in on the logs, and they might filter in a different way, each of them. There's a bunch of those that are provided out of the box. In the new, the lean startup that you also find with minimal web APIs, or if you do .NET 6 or 7 based applications, you'll see that the builder.logging is your go-to place where you configure everything and where you would register all the log providers that you would want to have. So that's all the adds that you do, add console, add debug. And this is how you can set it up and configure them, and that's pretty easy. Under the covers, what happens if you do those things is that there's a logger factory, and all the providers that you've added will be registered inside of the log factory. And the log factory will create the iLogger of T implementations. So iLogger is the thing that you can inject. Logger of T is what it actually is. And the T is the place where you want to use it. So usually the T is a type for your controller class, for example. Now, the things you do with the logger is you log things and you have all the severity levels nicely given to you. So it's all the way from critical, this is over, game over, to the trace and the information. I believe they're not in correct order of the significance, but debug and trace are the lowest ones in terms of very noisy. So things that happen inside of a loop that is iterated many times. Probably if it would be significant, then you would do trace or debug, so that you know that it doesn't surface in just regular logging, because that would just flood the log provider. The severity levels and the categories, you can see the real order at the right. The hierarchical structure of the categories is much like namespaces, and that allows you to be very specific. If things come from this category, this is the level that I want to add to it. The string for the category with the separation and with dots is determined if you use the logger of T from the namespace and the class name or the type name. So you see that if you have a namespace with the web API controllers and you have a class leaderboard controller, that will be your thing. And you can choose at what level you want to specify what the severity level is and for which providers it's configured how. So filtering those log messages, like I said, if you use ilogger of T, it goes to multiple places, every log provider registered, but you would configure them probably in this way. So that's from your app settings JSON or any other means that you can influence the configuration system. You'll do a configuration of your providers with this information, and you can see that there's a default section that is just log level. And then you say, okay, for default, so if that's for everything, it's information. But if it comes from Microsoft, so Microsoft dot something, extensions, dependency injection, that would be warning. But if it's hosting lifetime, that's the startup of your ASP.NET Core application or your worker service, then we want information again as well. So a little bit more information to see what is happening. For each of the providers that are specific and different, you would add a new section that gives you, well, in this case, console. So that's with add console. You would log to that, and you can specify a different log level. Same section as above, but you can tweak the values in a different way. There's things with scopes that I'll skip on today, but you can scope multiple log messages together because they belong together. And if you need to say include scopes. All right. We'll have a look at that with some things. All right. Let me see. There we go. All right. So what I have in this demo, and I'll show some stuff now, so we can later at the closer to the end we can have a look at how to collect all this information. It's a web API with a web app, and it kind of looks like this. Let me just start it again. So this is, by the way, the health check. So if it comes alive, we should see that this is going green again. And let's see if it's starting up. There we go. We'll get back to that. Let's see if we refresh this, that we have visuals. Yes, so this is the web API. What it does, it uses Entity Framework Core to retrieve some high scores, some seeded values. So if you try this out, and we ask for JSON, and we execute it, we'll get this bit of information here. That's the seeded data. If you go to the home page and refresh that, you'll see that this web application is retrieving the data and displaying it here. Health checks are okay now, so application is running. So how do we get to that? That would be here. Let's go to Program CS. So here we have the log providers. I've added the application insights, so remember this for later on. This means that we're sending out logs to application insights. We also add sec, and I'll explain that later on. And we have the simple console that outputs it there, which you can influence, how do you want to do it? Do you want to have the color behavior or just ignore that? So essentially we have these two, but by using this thing here, the create builder, and I can show that in the web app as well, where I use the old type of startup, where we have the create default builder. Now let me zoom in just a little bit. You see that let's try that again. There we go. So it says that the Logger factory is configured to do console, debug, and EventSource in this line here. So those are the ones you get for free. And if you don't want to have those, you could essentially, if you start configuring your log providers, you could start with a clear providers. So that these are all the things that you could add, the sec, the simple console, systemd, trace. But clear providers allows you to start with a clean slate, and then you add the stuff that you only want to have. But usually for debugging, let it just do console and debug, and the event source would be just fine. These are added. But if you want to be really optimized or in control, then you can clear it out. All right, then the other thing, once you start using it, you can do, you need to get to the logger implementation. I'm showing here one strategy, that's the iLogger factory. If you have that injected, you can create your own logger, and you can create multiple ones. So you don't have to do multiple iLogger of T injections and keep them all together. Suboptimal maybe, but also if you want to control the category yourself, if you do a create logger without the generic, you can specify the category name yourself. So that's when you can tweak it to whatever it is that you like. And once that, you start logging. And what I've done here is, for demo purpose obviously, we're doing a log error, log warning, log information to see how these are logged individually and with the different severity levels. And we'll get back to these statements here and see what is happening. But if we go back to this, to here and run it just once more, then it's kind of hard to see because of all the things that are happening, but let's just stop this, go to the output, and then if we watch this just above the things here, let me see. It's kind of hard to figure out with all the noise that is there, but I believe it's there. Retrieving the score list with a limit of 10, that's the info, the warn, and a little bit above that, that's the fail for the error that we wrote. So we see those logs appearing down here in the debug window of Visual Studio. All right. Now, believe it or not, I used to study, or I have studied physics, technical physics in particular. So I had my fair share of quantum mechanics and quantum statistics. We learned that there's quantum state, and quantum state is kind of weird because, like a spin of a quark can be up or down, but it's actually both until you observe it. Before that, you don't know. You might have heard about Schrödinger's cat, the experiment, thought experiment. There's a cat that can, inside step on something, and then there's some poison, so it's a really weird experiment. But it might eat it or not, so it's either dead or alive. But if it's in the closed box and we don't know, it's half alive, half dead. So that's kind of weird. But as soon as you open the box, you observe, and then it forces you in one of the two quantum states. Okay, a little segue into how does this apply to messages and log messages. I like to think of it that there's the same duality. It can be both. What do we mean? So first, logs are for us. We want to read and see, okay, so we're retrieving something with a search limit of 10. That's very good that we can read it as humans. But for a machine, if you want to do, the non-human side of things, it's kind of hard to look at that line, and you probably need regular expressions or say something to say, okay, these are the meaningful words and things, and the 10 there, that's actually what we want to have. So, sometimes you want one, sometimes you want the other, and it's, but it's when you observe it, you would want it to be either one. So, and a lot of the logs that we write are just textual things, so just the line of with some string information. But we would like to have the other side as well, because we knew when we logged the message that we pushed in the limit, that was a significant number to us. So semantic logging or structured logging is what solved this problem. And you already saw this line just a moment ago. It seems, like obvious. It's like, yeah, it's just a formatted string there with some string interpolation. But if you look closely, this thing, the search limit, it's not a 0. It doesn't match up by name, so it goes together in a positional way. But the left side of it is so the string with the curlies, that's the template that we have. The limit is the value, and they are kept in the one state. And if you want to have a string, it's put together, and then you get the string. So it's either regarding your observation. Now, not every log provider supports that. The ones that are out there and used pretty often are SAC, which goes together with Serilog, but not necessarily. And you have application insights. Those are capable of storing that information, that rich information, and keep it separate and put it together if needed. So let's see that. So we already did this logging here, and just to show you that it has this template and this placeholder, and it has the limit. Now, if we start this running again, I'll show you that this is all in a Docker Compose. So in the Docker Compose, we have the composition of the web API and the web app. That's the moving parts of our application. And then we have the override that shows the configuration for the web API, the web app, and then it says the database, so we can test with the database, but it also has SAQ as a container. So we're running the place where we would want to store this semantic data. It's running from this sec container, and it's running at this port 5341. I believe that's the default port if you run this yourself as well. So you can run it in an official production environment, but I'm just running it from a composition so I can neatly test it. Which means that if we go to here, then if I just refresh this, or do it like this, so we go to the thing here, we have this, and then we can say, okay, so we were looking for the logs that said retrieving, and these are the ones that we have. Let's create one with a different value, so we can see that up here as well. So let's say 42. All right. See, 42, 3 times. You see the dots here for the severity level, where you can filter and just pick out the ones that are warnings, errors, or both. But if you open up one of these, you'll see that there's a lot of metadata attached, and this one is the one that we're looking for. So this search limit of 42, that's where we can say, all right, so we want to have this search limit, and it knows that it's a semantic thing, so bigger than 10. And you can see that it filters out based on the search limit. And now the tricky part is, once you have this in place, is to find the right terms, because this can search across multiple log messages in different locations. So wherever search limit appears, this will just find it. Even if there's more information there, it knows where it is. So I think this is extremely powerful if you want to drill down and dig into, and if you have domain terms like conversion or a customer ID that might be relevant. This is what will help you find that semantic information and correlate it all together in search queries. Now, for the logging, keep your logging separate. Applications should not be aware of the log providers that are out there. It should just say, this is what I want to say with this severity for this category. And your log providers and the filtering will take care of the rest. You shouldn't make any assumptions there. The other thing, your log severity level. What would you think if you had an exception? You know, you do a try catch and you do a log inside of there. Just think for a second, what severity level will you do? And you might think, well, usually I see in all the samples, it's like catch something, logger.log error, because we have an error, right? But it means that something is really happening in your application. And if you have alerts triggered to, okay, if there's errors in our application, we need to know about it. But catching something in a, you know, in a way that we predict might just be informational or even lower. Like, okay, we took care of it, you know, we caught it, it's all fine. So be wary of the severity level and choose it carefully, because as a DevOps person, you might be paged with PagerDuty, VictorOps, or whatever tool you have for on-call moments, that you'll get, you know, oh man, okay, so it's catching all the timeouts because sometimes the connection is slow to this other thing that we're calling. All right. Now, logging. We covered logging. Then the next part is about tracing. Tracing, there's two sides that I would like to highlight. That's the stuff that you probably already saw from the very, very beginning of .NET. And then there's new stuff that has been introduced in .NET 5 and onwards. So I call it the good old diagnostic trace, is where you don't just do log, but it's trace .debug or write debug, or you can write stuff to the trace. With tracing, remember that it's about the flow of your application. So you need to indicate, so this is what is happening now, this is where we are, this stage, or these are the variables. You can just trace everything, and it can be high volume. The good thing is that if there's no one listening, or it doesn't even matter, but there might be someone listening or not. If there's no one listening, it disappears because it's not logged. It's just sent out like a radio show. If somebody's listening, then they can choose to do with the information what they like. Otherwise, it disappears. And it allows for a publish-subscribe pattern. So you just put it out there. You don't know. You publish it. And there might be 0 or more subscribers. You'll find most of this in system diagnostics. That's just like it was at the very beginning. And the two things that you have are trace and trace source. Trace is the oldest. Trace source is a little bit newer. And thing to remember, and we'll get to that, is it uses activities. And that's significant for our story. But the two sides is that with the trace, that's very easy to use, because with trace, you have these options to do trace error, trace warning, trace information. Those are the three. Or you can do write and write ifs. And write ifs are conditionals. But it is evaluated, the if statement, so it does take a performance penalty. But it allows you to send out information any place without having to inject things. So inside of a complex calculation algorithm, you don't have to, you know, with classes, object model, and all the way down there, you want to trace something, you can just say trace.write and write out something. Very convenient, instead of having to inject ilogger of t and pass it around all the places where you need to use it. The trace source is a little bit more modern. It has things where you control the trace data. You can trace events, which can also be significant. That's another way of doing it, but you need to wire that up with statics yourself. And both of them have switches, so you can turn it on and off if needed for a situation where you would like to investigate. So you can switch it on and off, almost like a feature flag. There's a bunch of listeners out there, so where it's being sent, or who are the ones that can subscribe. You can see that they are available from .NET Framework 2.0 is what I found. And .NET Core has its own implementation of the trace listeners as well. Those are more and more cross-platform, so they will work on Linux and macOS as well. Now the activities, that's kind of a cool thing. Activities are structures that allow you to have contextual information at the place where you're in. So it might be call stack or information regarding your trace. And that's being managed for you by the activity class, and it travels well across the various threads. So when you create one, even if you do async calls or then it will just travel accordingly. And if you ask for activity current, you will get the right one. So no concerns there. With activities, typically you add some metadata to it, and then you say, okay, this activity will start now. We'll start doing it. And from that moment on, this activity is like a little bubble, and things will happen inside of the bubble. You can spawn child activities, and they are related to one another. But everything that happens inside of an activity is correlated to the same thing. So there's correlation inside of activities. You can send out stuff that happens inside of your activity, so you can track some particular flow that you have. It even works distributed. So if you have calls from one place to something else, like we have from a web app to our web API, you can send out information along with the call out there. If both sides play the game, they know that they're working on the same thing, and a new activity on the other side, other process, will start based on the original one, so we can be correlated all together. So you can see flow from one thing to another thing based on those activities. And there's two things that make good use of this, application insights and OpenTelemetry. So if you're into OpenTelemetry, it uses activities under the covers, as does the application insights. All right. So I'll show that in code so we can get back to it later. Now, there's one place in our API where we can submit new high scores. So that's the scores controller. The scores controller allows you to do a post for your nickname and your game. And what we do here is we have this activity, we set the start time, that's done automatically, but if you choose to do it differently, you could do so. We can add tags to it, so we can add the tag gamer with the nickname we just received. We do our things, so we start an operation on a telemetry client that's being injected from application insights. A telemetry client being injected. And then we say, okay, so start an operation for dependencies. So we want to, see we're calling something that is a dependency, and this is the activity that should track this operation. And then we start doing things. Now, this is obviously a local dependency to a database. We can see later on that databases are already done at the Azure level, so we can see a lot of things there. But just imagine that this would be some other thing that you're doing that is a dependency for you. In this case, it's just Entity Framework Core. And at the very end, I'm showing two things. So we're tracking an event, because if we passed all the way here, as we essentially received a new high score, and that's like, ooh, new high score in the leaderboard. That might be something that we want to track. And we put out this metric, so this number for the high score, that tracks the value with the points of the new high score. Doesn't really make sense, but this could be a sale in your web shop and the total amount of your sale. And then you could see, what's the sale doing if that is important. All right, so let's just trigger this for a second so we can perhaps see it later on. So we'll do a post here. We'll try it. We'll say LX360, that's my Xbox handle, and then I'm not sure what game we should do. We already had, let's do Galaga. And we have the magnificent score of 1, 2, 3, 4, 5, 6 executed, and we got a 200, so everything worked. Let's do a new one. 1, 2, 4, 0, 0, 0, a big score. All right, so two new scores. All right, and we'll leave it at that, because that's kind of the gist of it. It's not more than that, but you have to do things for it, in this case. The activities are also in a lot of other places in .NET framework itself, so .NET 5, 6 later on. If you make HTTP calls, activities are doing the same thing without you knowing it. So there's already a lot of these things taken care of for you. All right. Now for the new stuff, because this is what you will easily find. A little bit more obscure, but all the more powerful, is the new system diagnostics tracing. So we just talked about system diagnostics trace, which is a class. This is tracing a namespace. And inside of it, you'll find a bunch of stuff, but two important ones are event source and event counter. And event source is, can think of it of the tracing and logging side, and the counter is about the metrics. Now, if you put this inside of your .NET application, and we're talking .NET 5 and up, it will use an event pipe to push that out. So event pipes are something similar to what is for LTTing or event tracing for Windows, ETW. That's your conduit out of your application to somewhere else, out of process. The event pipe is cross-platform, so it doesn't tie you like ETW does to Windows or LTTing, that's Linux-based. It works even for Mac OS. So event pipes are a good thing. You'll probably not interact with the event pipes directly, just know that under the covers, they are there. And then you have your consumers. So again, it's kind of in the tracing and the emitting thing. So you'll have consumers, a couple of obvious ones, application insights, and you have .NET tooling for .NET Trace, .NET Counters, .NET Monitor, but those can pick up all these things streaming out that you are emitting with event source and event counter. If you would like to, and if there's any reason, you can do it in proc as well, so you can have your own event listener and listen in on your own events and maybe use it for health information or some other thing that you come up with. So this is the way it works, but focus on the left with event source and event counter. Now, the event counters, they are a bit like performance counters, but that's again Windows-based. This is more cross-platform. And in .NET, in the runtime, the CLR, there's already a lot of things in there. This is just one section, system runtime, and you can see what is going on in there. So the obvious ones are CPU usage and the garbage collection related stuff. So you can see what is going there. Your working set, that's the amount of memory that you're consuming. So you can see, are we like climbing and maybe have a memory leak? You could already view that with these things. And those are available out of the box. All of your .NET applications from .NET 5 onwards already had this, maybe without you knowing it. You can create your own counters. It's not that difficult, but then you can emit some specific information. But these are the ones you get for free. And if you want to implement them yourself, then you can use a couple of classes. You have the event counter and incrementing event counter. And the event counter is about values. So you give it values and it can see the trends and it can do averages or statistical things on a time series. So we can say, okay, what was the max and the minimum inside this time period? What are the averages? The incrementing event counter is more about rates and frequencies. So you can see certain rates of how fast things are happening. So it's per time. This is where you write it, so you give it. The other one, the polling counter and the incrementing polling counter, are two different versions that allow you to, they will ask you for the information and you can do some logic there. That's inside of a Lambda expression. Now in the example that you see there, we'll cover that in code in a bit. That's where you see that you need to have a frame event counter and do increment, and you can even write events. So that's the eventing side of things. But this is the little bit of code that you would need, and then you start calling that from somewhere in your application. So let's see that in code as well. And for this, I have a different scenario. So in this case, you'll see that in a bit. This is a little racing game. It's 8-bit, but it uses a backend that is a UDP-based socket server, and it receives all the information from people racing, and it sends out UDP package through a socket all the way. But at least it's doing something, right? It's just 5 times per second. It's emitting all this information. Now, all right. So what is in here? So the most important part is this event source. It's the game server EventSource. It's derived from EventSource. You can give it a pretty name, which is kind of like the category. This is the name of the provider that we're creating in this way. So this is something that we can see happen or encounter later on. It has the incrementing event counter and an event counter, and we create those, frame event counter. It has a frames per second. It's per second, so that's the rate time scale, and it has a nice descriptive name, as does the lab event counter, because every time you pass a lab, you will get a lab count that increases, just to show some things. And then if the race is started, you can write stuff, so write particular events, but this is another way of writing the events, and it uses the map name combined with the message here. So race started 4 is the template, and this 0 takes this name, and it takes it literally as the variable name. And the frame sent, that's the one we saw on the slides. This sends out that information. So every second, this is incremented. This is actually a 1, but if it's something different, it's a double value that you can add here, but by default it's 1. And we're doing 1 frame every time we send this thing. Now it's a class with a static that creates a singleton. So that's this thing here, which means that if you want to use this somewhere in our code, this is where it would be. So this is the update method. For any of you that did game programming, you have an update loop. That's the game loop. We're sending frames here, but this is the point where it actually happens. So there we do the log. That's the thing that we just, the singleton, server same friend, server frame sent, and then we give it the map name, which was part of this update and this class. Now, with this, we can run this. So it's building now. It will start in a second. All right. So it has started. I'll put up 2 of these things. We need to connect to it online. You see that something is happening here, like it's send out the game list, so it's really doing something. And then we say, okay, log in, connecting, and if all goes well, timeout, let me see, yep. All right, there we go, the other one, let's connect that as well. Connecting, I hope that works. But anyway, we already see the information there. So this might just time out. Let's try that one more time. Oh, now it's already connected, so already logged. But okay, anyway. So stuff is happening. See all this blue stuff, and it's changing all the time, because here you can see the numbers that are passing by. And now we go here, and we would do something like .NET, counters, PS. That gives me all the processes that are able to be used by this tool at this moment. So we will look at the counters that are emitted. We need to have this one, the game server, which is 20364. So then we can say, okay, which ones are there? So you can say lists, and then do it for a particular runtime version. Well, let's runtime. Let's skip that. So these are the things that you have. This is for .NET Core version 3.1. You can see that there's system runtime, there's ASP.NET Core hosting, but since 5, and I'm not sure why it's still at 5, but since 5 there's system.NET sockets, there's security, name resolution, HTTP, so there's a bunch of more stuff, not just the system runtime. All right, now the other thing that we can do now is, and this is not the correct one because we had, does anyone remember the number? Let's check again, 20364. All right, 20364. Now it will wait a little bit for all the information to come in, and if you don't specify anything, it will do system runtime and show you all the stats of the things that are there. So that this you can do with your ASP.NET Core application, just do this, and this was already there. But we had some custom stuff, so we need to 20364. What I'm doing here is providing this counter, and the other one that I would like to see is system sockets and system runtime, but only the CPU usage. So there's square brackets here to filter that down. And if I do that, then we can see that it says system socket. So it's actually showing us, so 5 times per second, you can see that this thing is going up because it's 5 frames per second. So we're hitting that rate. And we can see the frame rate here, but that's the thing that we emitted as well, is running there. And the CPU usage is pretty low at the moment. So this could be, anything of your stats. If it's calculation engine, the speed of processing, number of conversions per hour, those things can be emitted here. And this is now streaming from here and ending up also in application insights in a moment. All right, so let's move on. I put this in for reference, but there's a way to monitor these kind of things with .NET Monitor. You can do that locally or in a container, and you can install it as a tool as well, but this allows you to watch your things, and if you look at the API endpoints, you can see that you can get metrics there, you can force a dump, and some information on what is happening there and the logs, just as an endpoint to listen into it from this thing without any additional tooling. All right, now, we've done a bunch of stuff. So we did metrics, we did tracing, we did logs, we put it all out there. But how do we see it? Because if this is running in Azure, what good will it do to us? Well, that's where you say, okay, we want to monitor it, but also query and analyze it. This shows application insights, but this is equally true if you have any of the other APM tools. And the functionality might vary. But in this case, I've chosen for this setup where the Azure resources use App Insights and Azure Monitor, like we discussed at the beginning. Now, what happens with Application Insights, you can connect that to your web app, your web APIs, all the dependencies that you have, and the other stuff. And the other stuff, the more is in Azure, the more you will get from it. Other external services, you might need to do some things with the telemetry client and help out with, I'm now making a particular call that is with a weird protocol, for example, and I'm doing that with a client library that doesn't know about this stuff. But you can help there and specify what is going on. All right, so if you instrument Application Insights, it will send it there. Any dependency calls or HTTP requests or other things that are well known will be put out there. Any framework core also plays this game. And then the background services are just .NET implementations, so they can be instrumented with App Insights as well. Now you can do logging and tracing, so you can do trace listeners to have App Insights trace listeners. You can do the logging that we already saw, and you can use the telemetry client, which allows you to write those events and put out the statistics and the information as well. So metrics and traces. We looked at the start operation, track event, we saw those. Now, and we had the new stuff, right? So the event pipe, this is just a reminder to the previous slide. But from App Insights, you can send this with a telemetry module, but you have dependency telemetry modules. But there's two other ones, the EventSource and Event Counter, which obviously serve either one of those. Now, if you want to use .NET Trace, you can use Purview, which is a low-level, ugly tool that's been around for ages. It works well, doesn't look as nice. But that's where you can just see all the information. If you gather it yourself with .NET Trace, you can collect it, store it in a file, a .NET Trace file, and then you can observe it yourself. But otherwise, we'll jump into Application Insights. So I'll hope that we can get to see this picture here. Let's just stop this blinking stuff. We'll go back to our I'll quit, and then we go here. All right, so let's go into this App Insights instance where everything is being logged to. It's smallish, so I'm missing the sidebar, but this works. So let's see, with all the activities that were built in and that we were doing, let's try to see the application map. So what it will do now is gather all that activity information and put it together. And then you can see this is what we did just a moment ago. You see all the information, and I'm trying to get this in view. So that's the sec call that we made. this is actually our activity got new high score. Remember that we created that? So because it was registered as an operation, as a dependency, you can see that it seems as if we're calling something external, right? So that's you can see, ooh, that's part of my application. We have the key vault calls, we have the SQL calls to Azure SQL, and we have the call from our web application front end, which was instrumented, to the web API that is here. And this one is also calling this thing here. And if you want to have details, you can see that it's the key vault that we're calling there. You can see that if there's errors, you can drill down into them. And let's just force an error. And I need to see if we're still running the application. We're not, so. All right. So there's also live metrics that you can see. Live metrics should be popping up. So you see that there's now 2 servers online. 2 servers meaning 2 pods in our composition, or sort of 2 containers in our composition, the web app and the web API. They are both thought of as servers. And you can see that things are happening here, and there are things going wrong. All right, so that's a good thing that we can see it. Not so good that that something is going on. So if I do limit, and I do limit is 1, you can see that I only get 1. But there's an intentional bug. If I do 0, it's in a very long loop, not even a thread sleep. And the front end decides this is taking too long, I will terminate this. It uses poly for that, but it gives us a timeout exception. Now, in a moment, we should be seeing more things coming in here. You see the exception that it just passed by, because that's being logged and detected. Now, for the sake of time, I'll go to show you a bit about the metrics that we can also collect. So we have log-based metrics. The metrics that are there are about availability, about the browser, that's all App Insight stuff. But here we have the custom ones. So again, you see this frame rate counter. If we choose to see that, and for example here we had a bit of a difference in the frame rate. So a bit dropped to 3, not too bad. We could also, let me see, add metric. So we could also see what about this high score. So let's see if we already have that average. It's giving me some data, no or not, just yet. So refresh this. Okay, that might be coming later on. We could say, okay, do the last 24 hours, because I obviously tried this before. And then you can see that there were scores being sent in. All right, so this is just the number of the score, the average there. We had a very high score a moment ago. Then we have the logs. And this is where we can say, okay, we have logs, for example, traces. Let me just quickly, to avoid some typing. All right, let's run this. The where operator failed, I'm not sure. All right, let's do it differently. We'll go to the logs, push out this, get rid of this, and just say, okay, let's see all the custom metrics. I believe that's the one. Run it. Now you can see that there's a lot of heartbeat state, but there's also the values of our frame rate, for example, and there should be things with the high score, excuse me, also here somewhere. But this is where you can do the filtering as well. So this is all the traces. But you can do similar things as in sec to filter out the semantic logging information and get that info out in your thing. So let's see if this one would work. Let's hope it does. See, there we go. So the race started. That's because we started 2 players, and it's being sent out, and it has these custom dimensions. that is about the map name, for example, that was put in there. So this is, again, where we can filter based on those things, as we did just a moment ago, custom dimensions and event names. All right. Wrapping up. So what we saw in this session is we were able to do the things with the logging, tracing, and metrics to make our things more observable. Just a glimpse of App Insights on the richness that is in there, but you can get all the metrics. You saw the graphs, you saw the log information, play around with it. You can do troubleshooting, end-to-end investigation, and that's where it's very strong. The alerting is just a matter of create an alert, say which metric, values, boundaries, and it will help you raise alerts on availability from your health monitoring or your metrics and the trace information that you have. That's all I have for you now. We've got these reasonably covered, and I would like to thank you very much. We're out of time, but I'll be here for any questions and answers.